Our geometric mean, so like, again, we have to take ourselves all the way back to chapter 7, where we talked about geometric mean, SOHCAHTOA. So this is the furthest back from where we started from. And geometric mean, the equation looks something like this. And what that means is typically the same thing shows up twice in two spots in our proportion. So for this example, this example up in the upper right is an example. Oops. This is an example of geometric mean there. And so remember, this is where we said this x is shared by these two triangles here. So in order to solve this, we would say that x goes with 20, and then 8 goes with x. And so in order to solve that, we're going to cross multiply. Hi. Yeah. And then we'll take the square root of that. Oh, it's 160, not 120. And so we get about 12.6 for our x. Once we know that, then finding the y and w should be pretty easy, because then we get to use Pythagorean theorem. So that was something we learned about in this chapter as well. So Pythagorean theorem, so a squared plus b squared equals c squared is used for right triangles. And we're able to solve that because if we know this is the square root of 160, I can do Pythagorean theorem twice to find my y and w. Now again, I like using the square root of 160 because when I square it, it just becomes 160. So I'm going to do 20 squared plus the square root of 160 squared equals y squared. And I would do the same thing for w, which I'm not going to take the time to do. But I'll get 400 plus 160. So then we take the square root of 560 to find out our y would be about 23.7. And again, we do the same thing for w. Questions there at all? So we learned about the triangle inequality, and that's what formed a triangle. So in order to be a triangle, the two shorter sides have to be longer than the longest side. And as we're going through this, like, you can kind of ask yourself, will I remember that? Do I need to put that on my note card? Maybe put a little star by it, reminding yourself of, do I need to, or can I save some space and not bother to put that on my note card? So to be a triangle, we have to check if A plus B is greater than C. Once it's a triangle, then we go into like, which type of triangle is it? Is it right, acute, or obtuse? So if it's right, A squared plus B squared equals C squared. If it is acute, A squared plus B squared is greater than C squared. I always think of C being shorter in that case, and that's the longest side. And then finally, obtuse is the opposite. Now we had, sorry, wrong pipe. We had two types of special right triangles. Now technically you could probably get by without knowing special right triangles. You could probably use SOHCAHTOA. But they are nice to know if you notice the pattern with them. Sorry. So we had 45, 45, 90. And that's where the two legs are both x. And then the hypotenuse is x square roots of 2. We also had 30, 60, 90. Where the short side we call x. The hypotenuse would be 2x. And then the middle side would be x square roots of 3. No, not really. I have this, like, I drink the oatmeal, but like a little chunky. So I'm a chunk. Alright, so if we have, let's say I give you that this is a 30, 60, 90, and I tell you this is 6 square roots of 3 for that side length. So again, this is a 60-degree angle. Now we'll talk about that we could actually use SOHCAHTOA for this, that we'll talk about in a second. But if you realize that this is a 30, 60, 90, we can actually do this without even using a calculator at all. So we know the middle side. So to go backwards, we're going to get rid of that square root of 3. So what's the short side going to be? 6. And then the hypotenuse will be 12. So if you can realize that, it's quick. But if you're like, oh my gosh, I never remember that, I always mess it up, I'll tell you guys, Pythagorean theorem, SOHCAHTOA will work for you just fine. Like I'd be fine on the test if you did it using SOHCAHTOA, as long as you're getting the answer. So what we learned with SOHCAHTOA was we kind of learned two different things with that. We learned that in order to find a side, we'd use the sine, cosine, and tangent. So this is defined as side. But then we learned there was these other buttons right above the sine, cosine, and tangent that were the inverse sine, inverse cosine, and inverse tangent. Do you guys remember what they help us find? Angles. So if we need an angle, the inverse is our go-to. So like, I'm going to ask us to find like an angle over here. Like I'm going to ask us to find like angle A, and we would then use the inverse sine, cosine, or tangent. So we'll do a couple of quick examples of this. And this is chapter 7, then I'll give you guys time to work on chapter 7. I think in past years with block scheduling, we try to get through a couple of chapters a day. So it's kind of nice to just do one and just focus on one thing at a time. So for this first one here, we have our 52 degrees. I like to label the hypotenuse, opposite, and adjacent. Now since it's adjacent and hypotenuse, we're going to use cosine. And so we're going to do cosine of 52, it's been a while since we've done this, equals a over h, so that's x over 17. So in order to solve that, we have to undo that. So rather than dividing by 17, we're going to multiply by 17 to both sides. So 17 times the cosine of 52 will give us our x, which ends up being like 10.5. And I like these because they make some sense. It's like seems logical that 10.5 looks reasonable for that side. So the next one, I want us to find angle A, and I also want us to find x. So we're going to find both things in this case. Let's find angle A first. So again, with angle A, we have our, we have our opposite, hypotenuse, and adjacent. So since I know these two, I'm going to use cosine again. So I'm going to do cosine of A equals adjacent over hypotenuse. So what we're going to do is this is where we use that inverse cosine to find that A. So of that fraction, we're going to do the inverse cosine of 3 squared to 2 over 40. Now, if you're not getting the answer that we get on these, it's really worth checking to make sure the calculator's in the right settings. I know like my trig class has been using my calculators from time to time, and sometimes they switch it over to a different setting. But we should get, is it like 50, no, sorry, no, like 80, 83.9. So kind of a weird triangle, but the drawing's not very good. So that'd be 83.9 degrees. And again, if you're not getting that, we can talk about what's going on in your calculator. That's totally a calculator thing, but you have to know how to use it. And then finally, we can find the x value by doing Pythagorean theorem. Or I guess you could use, you could also use like, sine if you wanted to. But I did want to show you guys we could do Pythagorean theorem here. Now 3 squared to 2 squared, we have to be careful about that's going to be 18. So again, when we do that, we want to use, you want to use parentheses when you do that. So that's my two values there. All right, so what I'm going to get back to you guys is I'm going to get some charts back to you. If you'd like a note card, if you want to wait on your note card, you can. I'll give you guys one note card and that's it. It's just a cardstock piece of paper. It's half sheet, so use whatever kind you want. If you prefer to use lino paper, you guys are welcome to do that. Oh, you need your review. So I'm going to give you guys the review. It does look long because it's all 5 chapters, but we're going to try to get through the chapter 7. So trying to do chapter 7 with this. I might draw a quick picture for you guys because number 7 talks about, it's a word problem, but I just want to make sure you guys remember, we talked a little bit about angle of elevation. I'll show you guys that. So we're going to try to get chapter 7 done for Monday. But, oh, I forgot he was out. Bad parent. All right.